In this video, we'll discuss problems and conceptual exercises of chapter 3 from the book James Walker. Now we need to express the sum vector A plus vector B plus vector C in unit vector notation, and for this we have to refer this figure. Okay, now to solve this, I'll be finding out the x component for each vector, then y component of each vector, and then I'm going to add the x component with the x component and y component with the y component. Okay, so let's start. So first we have vector A. So its x component would be A cosine theta, and theta we have 40 degrees, and magnitude for vector A is 1.5. So 1.5 cosine theta is 40 degrees. So we'll get this value to be nearly 1.1 meter. Next we can find the y component AY. So AY would be A sine theta. A is 1.5, sine theta is 40 degrees. So this value comes out to be as nearly 1.9 meter. Now next I'm going to find the x and y component for the vector B. Okay, so the x component would be bx. This would be b cosine theta. Now the magnitude of b is 2 cosine. Now students have many confusions here, that should we take theta as 19 degree, or should we take theta as minus 90 degrees, or we take this as our theta. They have many confusion, right? So actually this theta, we always measure theta from the positive x. So if you consider the coordinate system here, this would be our positive x, this would be our positive y. So this theta we should take. This is the first method that we can apply. This theta we should take, which is actually 360 degrees minus 19 degree. Either we can solve this question by using this concept. Other way around, you can use one more method which is very easy also. We know that its x component would be this, would be its x component, and this would be its y component. Now y component is along the negative y. So the by would be negative and bx would be positive, and theta we can take as it is. We can put theta as 19 as it is, and we know it is positive, so plus sign as it is. This is plus, and this value comes out to be as nearly 1.9 meter. And then by, this would be b sine theta. Now since it is along, this component is along the negative y direction, so I am putting negative here, and theta as it is, we can put it as 19 degree. So this is minus 2 sine 19 degree, and this would be equals to minus 0.65. So this is the easy way that I think, but if you find this method to be a little bit tricky, so you can always measure the theta from the positive x like this, and this would be 341 degrees. So you can put theta as 341 here, and now you no need to put this negative sign here. This angle will automatically get this answer to be negative. You can put as 341 degrees, because this time you are measuring angle from the positive x. Now automatically we will get this value to be positive, and automatically you will get this value to be negative. So these are the two methods which you can apply. Either methods, both methods are correct. Now next, the component for the vector C. So this is our vector C. So its x component, sorry, the y component would be something like that, cy, and its x component would be cx. Now x component is negative, we can see from the figure, and y component is positive because it's along the positive y, we can see it from the figure. So we can follow the same procedure, and we'll get this value for cy to be 0.42 meter, and we'll get cx to be equals to negative 0.91 meter. Now it's pretty simple. we can add the x component, vector A plus vector B plus vector C. We're adding its x component. So this would be AX, we have 1.1, so 1.1 meter, plus BX we have 1.9, so 1.9 meter. CX is minus 0.91 meter. So on solving it, it will get this value to be 2.1 meter. Similarly, the y component, vector A plus vector B plus vector C, its y component. So this would be equals to AY we have 1.9 plus BY we have negative 0.65 plus CY we have 0.42. So we'll get this value to be 0.74 meter. Now we can easily represent it in terms of its unit vector. So this is our vector A plus vector B plus vector C. So this would be equals to the x component, we have this value 2.1 meter. So 2.1 meter x cap plus y component is this value, so 0.74 y cap. So this is all with this question. If you find any confusion in this question, you can comment me in the comment box below. So here in this question, it is given that you traveled due west with a speed of 23 meters per second for 175 seconds, and then due south at 12 meter per second for 285 seconds. So this is our directions, east, west, north, south, and the north direction we are taking it to be positive, and here the east direction we are taking to be positive, and west and south respectively be negative. Okay, so first you traveled due west with a speed of 23 meters per second for 175 seconds. So what would be your displacement in the west direction? This would be equals to its speed multiplied with time, and since you are moving in the west direction, which we have taken to be negative, so this would be negative. This is minus 23 meter per second times t is 175 seconds, so that would be equals to minus 4025 meter. So you traveled this much of distance in the west direction. Okay, so let me draw the vector now. So this is your direction, and the length of this vector is 4025, basically its magnitude. Okay, then you traveled due south at 12 meter per second for 285 seconds. So what would be your displacement? Let this be R1, let this be R2. So this would be 12 multiplied with 285, and since it is towards the south, so this would also be negative, because north we have taken to be positive, so this should be negative. So this value comes out to be as minus 3420 meter. Now let me represent this on the figure also. This is R2. This is R2. And this was R1. Now what is your net displacement or total displacement? So this should be your total displacement. Let me show it on the figure first. This will be your total displacement. Now we need to find the direction and magnitude of your total displacement. Okay, so direction, this would be theta, and magnitude, it's pretty simple. Let this be RT. So magnitude would be under root R1 square plus R2 square, right? Now we can put the values. So under root minus 4025 meter and it's squared plus minus 3420 meter and it's squared. So this value comes out to be as nearly 5320 meter, or you can write this answer to be 5.3 kilometer. So this is basically the magnitude of your total displacement. Now theta, so You can write tangent theta from here. You can write that tangent theta, this would be perpendicular over base. Perpendicular is R2, and R2, this value is minus 3420. Base is minus 4025. And from here, we can easily find theta, and theta will be equals to 40 degrees. So this is 40 degrees. So we can write that the theta, the direction would be 40 degrees. This is south of west. So 40 degree south of west. And another way to give the answer is, we always measure our angle from the positive x-axis, or from this is positive x basically. So we can give this angle also to be our theta, which is 180 plus 40 degree, that is 220 degrees. So either you can write this answer, or you can write it's 220 degrees from positive x direction